So today I wanted to go over some of the general trends that we see in the periodic table. So these notes were things that we went over in class, but I thought it might be helpful for us to review those again one more time. So what we talked about is we kind of drew our janky example of the periodic table. So I'm going to try to kind of repeat that on here. And it doesn't have to be real pretty, but we're just kind of making a model of what the periodic table looks like. And what we then kind of talked about was across the top here, we have our group numbers. And so because we're kind of ignoring these transitional metals in here, we can, we have group 1 and group 2 on the far left. And then as we move right, we're going to ignore those transitional metals. And so we jump from 1, 2, and then we ignore those 10 transitional metals. So then we go 3, 4, 5, 6, 7, and then 8 are those noble gases. And so what I wanted to mention on here is sometimes you'll see some periodic tables where they include the numbers for those those transitional metals. So sometimes you might see 13, group 13, which is actually what we're calling group 3. Same thing, group 17 might be group 7 for us. And so don't let that confuse you. We're just kind of ignoring those transitional metals just to make things a little bit simpler for us. And then along the side here, we have our periods. And there are going to be 7 periods, just like there are 7 periods in the school day. So 1, 2, 3, 4, 5, 6, and then 7. So if I wanted to make this a little bit more accurate, I can kind of, I'm going to include those down there in the bottom. These go over, trying to make my erased too much of my periodic table there. And then again, as we were talking about, we're kind of ignoring these transitional metals in there. So really janky periodic table there. So I apologize for that. But those periods then, those period numbers over here are basically the rows across. So again, columns are the groups, rows are the period. And that's going to give us some real valuable information about each of those different elements as far as where it's placed on that periodic table. So as we learned in our last unit on atomic structure, the atomic number is equal to the number of protons in the nucleus of that atom. Okay, and so like each of those elements is defined by the number of protons. That is the atomic number. So if I change the number of protons, I change the atomic number, and so I change the element. And that's what we focused on last essential learning. And so if I have an example here, say, of hydrogen, which has a atomic number of 1, that means it has 1 proton. And if it's a neutral atom, it also has 1 electron. Okay. And when I look then at the periodic table, I find hydrogen, it's number 1, it will be right here on the periodic table. And so what I can say about that then is it is in group number 1, and it is in period number 1. Okay. Another example, let's say, would be oxygen, which has an atomic number of 8. So it has 8 protons. Its symbol is O for oxygen. And I find that on the periodic table, that is going to be in group number 6. It might be group 16 on some periodic tables, but again, we're ignoring those transitional metals. And so for us, it's group 6. Just know that on the test, on any assessments that we're doing, I will accept both answers. I will accept 6 or 16. It kind of the same group, so it's fine if you put it either way. And then it's in the second row, so its period number is 2. And then we'll just go ahead and do one more. I think, this is fairly easy kind of stuff. So if I look for calcium, which is number 20 on the periodic table, it is in the second second column up and down. So that's group 2. And it's going to be in the 4th row. So that's period number 4. Now, what's interesting about that group number and those period numbers is that tells us a little bit more about those atoms. And so one thing to kind of keep in mind when I look at, say periods. Oh, I'm going to go back to the using blue. I was using blue for periods. So periods, which are the rows. When I look at those, that is the same as the number of the energy levels. So for example, when we were doing the Bohr models, we were drawing those energy levels, those electron shells around those the nucleus. That's the same thing. So when I look at period 1, all of period 1 has 1 energy level. When I look at period 2, all of 2 has 2 energy levels. When I look at period 3, 3 energy levels, and so on. So the energy level is the same, the period number is the same thing as the energy level, or sometimes I will call that also the electron shell. Okay. More interestingly, when I look at the group number, which are the columns, is the same as the number of valence electrons. And remember that the valence electrons are those electrons in that outermost shell that are important for chemical reactions. And so when we start looking at chemical bonding and chemical reactions, those valence electrons are the electrons that are involved in that. And so because of that, those columns will have similar chemical properties. Okay, I misspelled that. Let's try that again. P-R-O-P-E-R. There we go. Similar chemical properties. And it's, again, because they have the same number of valence electrons. So let's go back and look at our examples. So if I look back at hydrogen, it was in group 1. So that means it's going to have one, okay, third time's the charm, 1 valence electron. And it's going to have 1 energy level. And so when I look at my oxygen example is in group 6. So it's going to have 6 valence electrons. And because it's in period 2, it's going to have 2 energy levels. And then if I look at calcium on here, calcium is in group 2, so it's going to have 2 valence electrons. And it's in period 4, so it's going to have 4 energy levels. And that's about as big as we're going to get. We're not going to look too far below period 4 because we're really focusing on the first 20 elements. And so if you can, know those examples, that would get you really set up well. Then the last thing that I wanted to talk about were the families. And families on the periodic table are labeled on your periodic table that you have on your desk that we use for class. And we're going to do some examples of those later this week in science. But in general terms, and I'm going to again kind of draw my janky looking periodic table here. And I have that kind of divided into 3 main groups. Okay, so I have my metals, which are on the left side of the periodic table. I have my nonmetals, and again, I kind of messed this up, but we're going to go with it. I have my nonmetals on the right side of the periodic table. And then in the middle here, I have what are called the metalloids. Kind of stuck in the middle. Now, we're going to talk more about the differences between metals and nonmetals and metalloids and so on. But for right now, what's important for you to know is just where those are located. So I have, again, my metals on the left side, which make up most of the elements. I have my nonmetals on the right side, which make up a smaller group of the elements. And then in between those, I have my metalloids. It might be helpful for you to go through and look at your notes as far as what are the characteristics of metals, what are the characteristics of nonmetals, and know that metalloids kind of have a mixture of both of those kind of traits. And so it's important to know that these families basically share similar physical properties. And that would be things like, their melting point, their boiling point, density, magnetism, are they good conductors or not good conductors, those types of things. So those are their physical properties. Similar chemical properties, remember, were the groups, so the columns. So, the groups or the number of valence electrons will affect their chemical properties, whereas, these families are more about their physical properties. Okay, so that should be kind of a good review. If you have any questions, don't ever hesitate to contact me, and we'll get you back on track. So thank you so much. If you have any questions, please let me know.